Today we'll be deriving special trig limits. This is part 1. My name is Ved Krishnan, and let's get started. So today, for this part, we'll be going over the limit as x approaches 0 of sine of x over x. This is, known as the most important limit for evaluating other limits without using L'Hopital's rule. Of course, because using your knowledge of trigonometric identities, you can manipulate things, and you can then apply this limit to evaluate that more complicated limit involving other trigonometric functions. So that's why we're going to be going over this first. So, without using L'Hopital's rule here, because, when people study limits, they don't study derivatives before limits. It's usually limits, then derivatives, etc. So I'm assuming that, for the knowledge base here, it'll be understanding limits and everything before that, so algebra, trig, etc. So let's first assume that we have access to graphing technology. So if we have access to graphing, technology here, we can first pull up a graph of sine of x over x. So then, understanding the limits, in order for this limit right here to exist, the limit as x approaches 0 to the left of sine of x over x has to equal to the limit as x approaches 0 to the right of sine of x over x, right? So if we see here, to the left of this function here, sine of x over x, we're talking about the limit as x approaches 0 to the left, we see that this would equal to 1. And then, of course, to the right, this would also equal 1. So then we can say, therefore, the limit as x approaches 0 of sine of x over x equals 1. Okay, so hopefully that makes sense. If you don't want to look at this graphically, you can also use your table feature on your calculator. So of course, if we plug in 0 here into the, we directly substitute 0 into sine of x over x, this will be 0 over 0, which is an indeterminate form. So the next best thing to do is to plug values that are super close to 0 from the left and the right, because that's essentially the same thing that we can see graphically what is occurring. So for the right, this is the right of 0, this is the left of 0. So we can say here for the right, I just chose 0.001, and it approximately equaled 1. Of course, it doesn't exactly equal 1, but the calculator is just rounding because it's super close. And then for the left, I picked negative 0.001, and that, of course, also approximated 1, approximately equaled 1. So then we could say, therefore, the limit as x approaches 0 of sine of x over x equals 1. So that's one. These are two ways of sort of doing it if you have graphing technology. But what if you don't have graphing technology? Then we can do a sort of geometric representation of this. So I'm going to assume that you guys already understand the unit circle, because that's part of trig and algebra 2 sort of stuff. If you don't understand the unit circle, I will be making a video deriving the entire unit circle soon, but if you're watching this video in the future, just check the description, because if I've already made that video, then I'll definitely link it down in the description of this video. So I'm going to right now draw a portion. I'm going to draw a portion of the unit circle here. Okay, just going to draw a portion. I'm not an artist, so I'm going to try my best here. I'm going to draw a portion of the unit circle. And what I'm going to do here is I'm going to sketch the definitions of sine and cosine. So first of all, the unit circle always has a radius of 1. Okay, so it always has a radius of 1. Okay, now according to the unit circle here, I'm just going to write this as angle x here, because we're dealing with x, with everything in terms of x. Horizontally, right, or the side adjacent to x is cosine of x, and the side opposite to x is sine of x. Okay, if you're a little bit confused, just remember, like, if you're looking at the unit circle picture or diagram itself, if you have some coordinate pair x comma y, this is known as cosine of x comma sine of x. So hopefully that makes a little more sense. Again, I'm assuming you, for the most part, already understand the unit circle. So we've got sine. We've made this right triangle here, which shows the definitions of cosine and sine. So what I'm going to do here is I'm just going to label this as triangle A, B, C. Okay, so now I'm going to sketch tangent of theta. So tangent of x. Tangent of x is just opposite over adjacent, sine of x over cosine of x. Great. So tangent of x should look something like this. Okay, so it should be, I'm going to call this segment DE, and this is what tangent of x should look like. Okay, so hopefully that makes sense. So now, sort of using maybe common sense here, let's say that this right here, this is triangle, again, not a highlighter, this is triangle ABC. This is sector ABE. And then this right here is triangle ADE. So what do you notice about the size difference, or the areas perhaps? So what you notice here is that essentially the area, or just triangle ABC, can be less than or equal to the area of sector ABE, and that can be less than or equal to triangle ADE. So now we can just, for all of the triangle ABC, sector ABE, and triangle ADE, we can just substitute these for our areas of all of these. So for the area of triangle ABC, that's just 1/2, right? 1/2 cosine of x, sine of x. And this is less than or equal to area of sector ABE. Hopefully you remember the formula for area of a sector. If not, you can just do a quick Google search. This will be theta, or sorry, not theta. This should be x over 2 pi times pi times 1 squared, and then this is less than or equal to the area of triangle ADE, which is just 1/2 tangent of x. Alright, so now I'm just going to multiply all parts of this compound inequality here by 2, and you should expect some sort of canceling out here. This should cancel, and also the pi should cancel here, cancel. So now we should be left with these are different colors here. Should be left with cosine of x. Why do I keep using red? I'm going to use black. Cosine of x, sine of x is less than or equal to x is less than or equal to tangent of x. So now we sort of want to get this in terms of sine of x over x. So what I'm going to do here is divide both sides. I'm going to say here by, or actually, you know what? Let me make this better. So one thing that you should know here is that the limit, I'm going to write a quick note. The limit as x approaches 0 of sine of x over x is equal to the limit as x approaches 0 of x over sine of x. Okay, so make that note here, that these two limits are equal to each other. Alright, Now, you can check this through a graph again, and it should make sense, because if you're plugging in your values here, it should be exactly like if you're plugging in 0.001 and negative 0.001 into x over sine of x, you should see that those also equal to 1. So hopefully that makes sense. You can test that using a calculator if you want. I'm just going to do this a little differently. So I'm going to divide all parts of our compound inequality here by sine of x, so then we can get it in terms of x over sine of x, because we know that, and you're going to see what I'm going to do here after, by the way. Let me just do this. We know the tangent of x is just sine of x over cosine of x, and then that times 1 over sine of x, right? Because we did that divided by sine of x. These two cancel here, and we're left with 1 over cosine of x. So then this should then equal to cosine of x, which should then equal to cosine of x is less than or equal to x over sine of x is less than or equal to 1 over cosine of x. So now we can just take the limit as x approaches 0 of all parts of this compound inequality here. Limit as x approaches 0. So now we can see here that the limit as x approaches 0 of cosine of x, that's just we can do direct substitution, that's just 1, cosine of 0 is 1, that's less than or equal to the limit as x approaches 0 of x over sine of x, and then this is less than or equal to the limit as x approaches 0 of 1 over cosine of x, direct substitution, that's just 1 over cosine of 0, which is 1 over 1, which is 1. So if something is less than or equal to 1 and greater than or equal to 1, that means that it has to equal 1. So then the limit as x approaches 0 of x over sine of x equals 1. So then therefore the limit as x approaches 0 of sine of x over x also has to equal 1. So hopefully that makes sense here. Sorry if the diagram's a little messy here. Again, with the limit as x approaches 0 of x over sine of x, you can just do the plugging in the values to the right of 0 and to the left 0. So hopefully you enjoyed this video. Sorry it was a little sloppy at times, but hopefully you understand. See you in the next one.